دنبش خطابي تيجا. Today we have the section 4, 10.4, we have polymers. In this section, polymers is very important molecules in our life. The polymers are large molecules consist of small units called monomers. Now the monomers is small units which contained in the polymer, and polymer is big molecule, and you must distinguish between them. It is very, very important. Generally, we can define the polymers as in your textbook are large molecules made of many small units joined to each one through organic reactions. The small units called monomers. Always the polymer name called by the name of the monomer. The polymers are all around us. The food we eat and the clothes we wear are made of polymers. Some of the most common natural polymers included starch, cellulose, and proteins. We can say we have two types of polymers: natural polymers, which seen in our nature, and synthetic polymers. We have two types of polymer generally: natural polymers and synthetic polymers. Yes. Example of natural polymers you have in your textbook: starch and cellulose, and we have also proteins. But synthetic polymers, we have many types of synthetic polymers: PVA, HDPE, and also we have synthetic plastic. We have many types of synthetic polymers. But the polymers are two types generally according to effect of warming or heat on it. We have two types of polymer: thermoplastic and thermostatic. The thermoplastic polymers melts when heated and can be reshaped many times. But in thermostatic polymers does not melt when heated, but keep its original shape. The thermal properties of polymers can be explained by whether these structures are linear, branched, or cross-linked, as shown. We have three types of polymer: linear polymer, branched, and cross-linked. In linear and branched, the temperature effect on the shape of these polymers, and we can reshape these polymers in different shapes. But in thermostatic plastics, the temperature does not affect on the shape of this plastic, and therefore remaining unchanged. Its shape remaining unchanged. Why? Because we have here linear polymers. The chain of the linear polymers slide to each other, to forth and back. You can say here the molecules of linear polymers are free to move. They slide back and forth against each other easily when heated. So linear polymers are thermoplastic. The molecules of the branch polymers contains a slide chain or side chain that prevent the molecules from sliding across each other easily. More heat is required to make or melt branch polymers than linear polymers. However, branch polymers are still likely to be thermoplastic. In cross-linked polymers, adjacent molecules in the polymers have formed bonds with each other. Individual molecules are not able to slide past each other when heated. Cross-linked polymers contain or retain their shape when heated, and the thermosetting polymers are this type of polymer will be thermosetting polymers. Thus means we have generally two types of polymers according to effect of heating on its shape: thermoplastic and thermosetting polymers. Thermoplastics are linear and branched, but thermosetting are cross-linked polymers. Now we have two methods to prepare polymers. We have addition polymers and condensation polymers according to the reaction used to prepare the polymer. In addition polymers, we have addition reaction, but the monomer must contain double bond. The additional reaction does not occur if we haven't double bond. If you have single bond, no additional reaction occur. But additional reaction occur in polymers when be unsaturated or containing double bond. Double bond. Okay. We have a type or example of polymer, of addition polymer. We have ethene or ethylene. This ethene will be polymerized as follows. We have a catalyst here producing this polymer. The N is unknown number, and you see that double bond doesn't obtain here because we have additional reaction. No, this molecule called polyethylene, polyethylene, or polyethene. Polyethenes are three types: HDP, LDP, and CP. HDP, high density polyethylene; LDP, low density; and cross-linked polyethylene. We have three types of polyethylene: HDP, LDP, and CLPE. The HDP are high density polyethylene because it is linear. Its chain is very near to another, and therefore its density is very high, therefore called high density polyethylene, which used to making the plastics of container of juices and Pepsi, Cola, and water and other uses in our life. But LDPE, we have branched between the chain of the polymer. This chain leads the chain of the branch leads to the chain of this polymer far away from each other, and then we have low density polyethylene, which used in the in plastics يعني ظرفة نايلوني جيتشتكن very يعني قالك نرمة. But cross-linked polyethylene, when we heated the HDPE to or polymer to 200 degrees centigrade and more than 200 atmosphere pressure, maybe the chain crossed with the other chain by making a bond with other molecule and producing cross-linked polyethylene. This type of polymer is very hard. Is very hard and used to making some properties or some materials in our life, such as a chair, door, and windows, other uses. You can see in your textbook you have various forms of polyethylene shown in figure 11. You have figure in your textbook, have different molecules structures. High density polyethylene is a linear polymer. It has a high density because linear molecules can back together closely. يعني قالها نزيكي. One use of HDPE plastic containers such as milk and juices bottles because HDPE tends to remain stiff and rigid. يعني قائمة بدل نوبة by heating. And if ethylene is heated to about 200 degrees centigrade and pressure above 200 atmosphere, random branching of molecules chain may occur during polymerization. Branched forms when hydrogen atoms are removed from the molecules and ethylene molecules added to these locations. Branched chain molecules are not able to cluster and closely together as are in linear polymers or molecules. Thus, the density of branched chain polyethylene is less than that of the linear polyethylene. The branched chain form of polyethylene is known as low density polyethylene LDPE. It is less than rigid than HDPE and used, for example, in plastic bags and ظرفة نايلوني. But cross-linked polyethylene, when hydrogen atoms are removed from the polyethylene, the molecules two adjacent molecules chain may bond with each other. This form of cross-linked polyethylene when between two molecules cross-linked polyethylene CLPE. This type of it is used for adjacent or objects that need to be very strong. أو ديفدا أو باراجرافا ديفدا أو بوليستيرين بوليسترز دفيتوان ناخويني أو أنا تناخويني تمام أو بوليسترا يو ديفدا تو ناخويني